Hello, algebra students. We are studying a very exciting section today, which is about the quadratic formula. Boom, boom, boom. We are solving quadratic equations by using the quadratic formula. You guys have already solved quadratic equations before, but today we're going to learn a new method, which is going to be using the quadratic formula. So why do we need this new method? Why can't we do what we did before? Let's take a look at this example. This is review from chapter 8. And this is an example of a quadratic that you guys we're supposed to be able to solve. Set equal to 0, you're supposed to come up with the x values that make this statement true. So step number 1, when you were trying to do this problem, what I told you guys to do is list the factors of the c term, which is 35 in this problem. List the factor pairs of that. 1 times 35 is 35. And 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 7 also multiplies to 35. From here, you would pick which of these pairs, 1 and 35, or 5 and 7, could add to the middle term, which is negative 12, and how. And hopefully you would come up with the conclusion that negative 5 and negative 7 adds to negative 12. And we also know that, of course, these things multiply to positive 35. So what you'd come up with would be x minus 5 and x minus 7 is equal to 0. This process we call factoring. And then what you would ask yourself is, what makes this parenthesis 0? And that would lead you to 5. And then you'd ask, what makes this parenthesis 0? And that would lead you to 7. This is when you guys learned it, you're like, oh, this is a lot of work or whatever. But this, in actuality, ends up being a pretty quick process to solve a quadratic. There's lots of different ways to solve quadratics, and they're, for the most part, much worse than this, including the quadratic formula today. So why don't we always just factor? If what we're learning today, the quadratic formula, is more time-consuming, more work, why don't we always just factor it? Well, the truth is, factoring only works sometimes. I have another example here. I've only changed the last number, 34. So in this instance, can we solve this equation? Well, we would do the same thing. We'd list the factors of 34, and you'd come up with 1 and 34, 2 and 17. 3 doesn't divide 34. 4 does not divide 34. 5 doesn't. 6 doesn't. No other factor pairs divide 34. So then you would go to these pairs and you'd say, okay, which of these adds to negative 12? And neither one does. And so historically, how you would answer this question would just be to say not factorable. Now, we're not going to do that anymore. We're not going to write not factorable. We're going to use other methods to solve them. And the great thing about the quadratic formula is it literally always solves a quadratic. Okay, it doesn't matter what quadratic it is, the quadratic formula can solve it. It works for any quadratic. So this example here, we wouldn't be saying not factorable. We would instead be using the quadratic formula to solve this particular instance. So what is the quadratic formula? Well, this is a poster up in my room you guys might recognize. Like I said, the quadratic formula can solve any quadratic equation, and it's given by this formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This is something that you guys should be memorizing. This is something that you're going to use a lot this year and in future years. There's like a little song. It's sung to Pop Goes the Weasel, very exciting. Or any other method that you might utilize to memorize this, but you will be expected to memorize this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So how do we actually use this quadratic formula? Well, good time to pause it here and write down these steps, and we'll talk about them. Step 1 says to set one side equal to 0. When we looked at these quadratics, both situations, one side was set equal to 0. That's always pretty much how you want to start solving a quadratic, is one side should be set equal to 0, whether you want to factor it or use the quadratic formula. Then you can identify the a, the b, and the c terms and write them into the quadratic formula. We know that quadratics are written like this: ax squared plus bx plus c. So the thing in front of x squared is a, the thing in front of x is b, and nothing at the end is c. What you guys are going to do is simplify the radical or the square root sign first, and you're going to use PEMDAS to do that. So I want you guys to simplify everything underneath the radical first, and then look to simplify your square root, just like we have been. and move from there. Then you're going to get rid of the plus or minus by creating two problems. So one with the plus, one with the minus, and then look and see if there's any simplification of your numerator and denominator that you can do. So here is a very fun example. It's very fun because it's our first one, and I think that's fun. We have the quadratic 3x squared plus 5x minus 8. So one side is set equal to 0. We're good on that end. Boom. Identify a, b, and c. The a value you should know is 3 because that's in front of x squared. The b value is 5 because that's in front of x. And the c value is the thing without an x, and that's at the end, negative 8. We need to enter them into the quadratic formula. So instead of b here, we're going to have 5. Instead of b there, we're going to have 5. And instead of a there, we're going to have 3. And negative 8 goes there. And 3 goes there. You are definitely going to want to have your calculator here. For the most part, any of your calculators are going to be able to handle this underneath the square root business. This should likely be in parentheses. It doesn't actually matter for this problem, but if it was negative, it would have to be in parentheses. So first step would be to enter all of the stuff underneath the square root side. Don't enter the square root side. So it'll look like this, negative 5 plus or minus the square root of whatever you get out here over, I guess, 6, because we can do 2 times 3. So go ahead and type this whole thing into your calculator if it's capable of doing order of operations. So you would have 5 squared minus 4, 3, negative 8, enter. And what I got when I typed all of that in, hopefully you guys are following along, is 121. So we have negative 5 plus or minus the square root of 121 over 6. Carrying on, next step is to, well, let's see if we can simplify our square root side. Sticking with step 3, can we simplify the square root of 121? 121 actually shows up in our list of perfect squares, which means that you guys should be able to type in the square root of 121 in your calculator, or even better, have it memorized and know that the square root of 121 is just 11. From here, you're going to break this up into 2 different equations. You're going to have negative 5 plus 11 over 6 and negative 5 minus 11 over 6. You are going to simplify the numerator. Negative 5 plus 11 is 6 over 6, which is 1. And negative 5 minus 11 is negative 16 over 6. And negative 16 over 6 reduces to negative 8 over 3. So when it's all said and done, your final answers are 1 and negative 8/3. We're going to do a couple more examples of this because I want to make sure that we understand it well. Let's go back a couple slides and try this problem. So we already tried to factor it. We were not successfully able to factor it, but we should be able to still solve it using the quadratic formula because the quadratic formula will solve any quadratic. So what we need to do is we need to identify A, B, and C. The A term here is 1, the B term here is negative 12, and the C term here is 34. Then we go through the quadratic formula and we enter these numbers in. I'm going to first write the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. Let's go ahead and fill stuff in. Negative 12 going in for b, because b is already negative, it would be negative 12, which actually ends up being positive 12. Plus or minus the square root of, make sure you put this in parentheses, minus 4, 1, 34 over 2 times 1. Right? I'm just entering 1 in, any time there's an a, I'm entering 34 in for that c, and then the b term was negative 12, and that's what I was entering. Then focus on the stuff inside the root. So it's going to be 12 plus or minus the square root of some number over 2. Simplify that stuff underneath the root. Your calculator should be able to handle that all in if you type it in appropriately. One more time, I'm going to remind you to make sure you type in this number with parentheses around it, or it will be wrong. When I typed that in, I ended up with 8. So I have 12 plus or minus the square root of 8 over 2. From here, what we should be trying to do is simplify the square root of 8. We've been working on simplifying roots for the past couple of days. What you're supposed to do is you're supposed to look at the list. Remember, the list is 1, 4, 9, 16, carries on forever. Do any of these numbers divide 8? And yes, 4 divides 8. So you have 12 plus or minus the square root of 4, because 4 is in our numbers, our perfect square list, and the square root of 2, because 4 times 2 is 8, over 2. The square root of 4 we know to be 2, so we have 12 plus or minus 2 root 2 over 2. We can actually do a couple simplifications here. We can break this up into two different problems. We have 12 plus 2 root 2 over 2 and 12 minus 2 root 2 over 2. That's a lot of 2's. Now this 2 in the denominator, we can actually divide this 12 and this 2 by the 2 and end up with 6 plus root 2, because 12 over 2 is 6 and 2 over 2 is just 1, so there's like a 1 here. That doesn't actually even need to be written. See if I can go back until it's not there anymore. 6 plus root 2. And then this one here, we'd have 6 again, and then the 2 over 2 cancels to 1, so minus root 2. And those are our two answers to this problem. Now, my guess is, and hopefully your guys' is the same, because these were such similar equations, 5 and 7 is going to be really close to the numbers 6 plus root 2 and 6 minus root 2. You guys could actually type out root 2. You can do 6 plus root 2 to get like a decimal answer, approximation for this, and you end up with like 7.41, which you're going to notice is very close to 7. And then if you do 6 minus root 2 in your calculator, you're going to end up with 4.59, which also is very similar to the answer of 5. What answer I'm looking for is this one here, but there are going to be times where you see decimal answers, especially in word problems. And so then you would just now type in the square roots and get your answers. Let's do one more of these to make sure we're understanding it well, and then I'll turn you guys loose to practice it. Here's the example. 2x squared minus 7 is equal to x. This one's a little bit different in that one side is not set equal to 0. So that's going to be your first step, is to subtract x to both sides. So you have 2x squared minus x minus 7 is equal to 0. Now we can look at this and we can say, okay, so the a is 2, the b is, the number in front of x here is -1, and the c is -7. We're going to go ahead and we're going to enter these numbers 2 in for a, -1 in for b, and -7 in for c. What we would end up with would be 1 plus or minus the square root of -1 squared minus 4 times 2 times -7 all over 2 times 2. Now, once again, you're going to go to what's underneath the square root and worry about all that stuff. So it's going to look like 1 plus or minus the square root of something over in this problem 4. And that something, I'm going to go to my calculator and I'm going to type it in just as it shows. -1 has to be in parentheses, squared, minus 4 times 2 times -7. When I type that in, I get 57. So your next step is going to be to try to simplify the square root of 57. And I could try to see if there's any perfect square factors of 57, but I know there isn't. 57 is already simplified root. I know that because if I were to try to see if any of these numbers divide it, they don't. None of these numbers divide 57, and so we're good there. We can break this up into two separate problems, though, so it would look like 1 plus the square root of 57 over 4, and 1 minus the square root of 57 over 4, and those would be our two answers. So that's been our lecture on the quadratic formula. Please let me know if you have any questions, and I'll see you guys around.